All right, so this question asks us to look at the system of equations graphed below. What is the solution to the system? Well, I've got two lines that make up a system. How do I find the solution? Well, I want to look at the intersection point of those two lines. That point, remember, is x comma y. That is positive 1 comma positive 5 for the y. So x should equal 1, y should equal 5. Should be that answer. Right, this question asks us which of the following relationships is a function. Remember, a function takes every input has exactly one output. So we've got to remember that exactly one output. So let's do B, C, and D first. So if I look at, or we can do the graph first. Remember, if you have a graph like this, the way that we can test to see if every input has exactly one output, we have to use our vertical line test. So if I take my pencil and like kind of like draw a vertical, like move it across the paper so I can do a vertical line, do I ever hit this graph more than once? Yes, I hit it right here and right here. I hit it twice right there and right there. So this will make this not a function. Okay. B, all right, I've got 0 is mapped to 2. Or I can do it like this. 0 is mapped to 2, 2 is mapped to 6, 5 is mapped to 9, and then 6 is mapped to 11. So wait, every input has exactly one output there. So that is a function. But let's look at C and D and see why not. Well, C is not a function because look, you got this 3, x equals 3 is mapped to 5, but then 3 is also mapped to 3. That's the same input having two different outputs. That can't be it. And then here you got this one. This negative one is with 0 and this negative one is with 7. So that's two outputs again. So that's also not a function. So that's why it has to be B here. Okay, for this question, we have a graph here, and the question is asking us the graph of a function. What is the range of this function? Remember, the range is all the possible y values of the function, all the possible y values. So where does the function stretch? Like, what's the highest point the function stretches? What's the lowest point it stretches? Because that is the y-axis. So range is up and down. So if I look up high, the highest y value that it stretches to is positive 15. And if I look down low, the lowest y value, well, I got to be careful. I have arrows here. These arrows mean that this graph is going to keep going down, down. So I'm going to go all the way down to what value? Well, it's going to be negative infinity, all right? Because it's going to keep going down and down forever. So wait, I can go from 15, the highest, all the way down to negative infinity. So it means that the y value can be what to 15? Well, it can be equal to or has to be less than or equal to, because the highest y that I'm at 15 is the highest y, and I keep going down, down, down all the way to negative infinity. So y can be less than or equal to 15. Right, this question says if f of x, all right, function notation, equals 3 parentheses 4 to the power of x plus 5, then which of these will be equivalent to f of 2? Now remember, f of 2 is just basically saying, all right, what is the answer, f of 2, when I plug in 2? So f of 2 is going to equal everywhere. This is my input, remember, because it's inside parentheses. It's my input. Same thing as saying my x. So everywhere I see an x, I'm going to put a 2. So I'm going to have 3 parentheses 4x. Instead of x, I'm going to put 4 to the second power because that's my input, right? Plus 5. If I do that, you don't need to put this in a calculator. This is just saying the answer when you plug in 2 is this. So put the right hand side, put all of this into the calculator. And if you do, well, you get 3 times 16 plus 5, you get 48 plus 5, you would get 53. That would be your answer. Right, this question asks us to simplify 6k squared, parentheses 6k squared minus 18, minus parentheses 9k squared minus 7k minus 13. Well, when I want to simplify this, I have this negative sign in front of a parentheses. It's an understood -1. So I need to distribute that -1 to every term inside parentheses first, right? Now, for this set of parentheses, there's nothing to distribute here. There's nothing right here, so this won't change. So I can leave this 6k squared minus 18. But when I distributed -1, remember, it changes the signs of all of these terms to the opposite. So instead of positive 9k squared, I'm going to have negative 9k squared. Instead of negative 7k, I'm going to have positive 7k. And then instead of negative 13, we're going to have positive 13. Now can combine like terms. 6k squared is like with negative 9k squared because they both have k and to the squared power. This negative 18 is like with this positive 13, and then this positive 7k is all by itself. So 6k minus 9k squared, 6k squared minus 9k squared, 6 minus 9 is negative 3k squared, put in your calculator. Negative 18 plus 13 is negative 5. I'll put that at the end. We like to put it in standard form. And or I could write it right here and then I'll rewrite it later. So, and then I got positive 7k, right? So you don't see that answer up here because they want it in standard form, so you need to write it as negative 3k squared plus 7k minus 5, like that. So it should be this answer right there. All right, this question is talking about an ice cream shop that basically has two stores, the old store and the new store. Both stores sell ice cream and milkshakes. 1 year's of sales at the two stores is shown in the table. The question is asking us, all right, drag and drop the correct value into each box to make your statement true. Round each percentage to the nearest whole number. That's important. Round to the nearest whole number. So the question, so basically I have these statements to fill out. It's saying customers at the old store bought milkshakes blank percent of the time, whereas customers at the new store bought milkshakes blank percent of the time, right? So it's asking me what percent of customers at the old store bought just milkshakes, what percent of the time did customers at the new store buy milkshakes. So that means I got to come back up to my table and I got to calculate a percentage. And remember, percents compare parts to whole, right? So if I try to figure out the percentage of that first, the old store, what percent of the time people buy milkshakes? I'm going to look at the old store and I want to look just at the milkshakes, all right, for the old store. That means that the part, all right, is this 10,400. That's the part of my relationship, 10,400. What's the whole? Well, I've got to look at the old store because I want to talk about the percent of the time at the old store that people bought milkshakes. I got to look at the old store and find this total, right? At the old store, the total of all the products that were sold because the old store doesn't only sell milkshakes, it also sells ice cream, just like the new store. So I got to find what's the total number of products that were sold. So I got this 49,700. I got to add that with the 10,400. If I add that, I get 60,100. So the whole of all the products sold at the old store is 60,100. Now I've got my part to whole fraction here. So now I just got to put this calculator and get a percentage, get a decimal, and then a percent. The decimal here is 0.173. If I multiply that by 100, I get a percent because to get a percent, I multiply by 100. That would give you 17.3%. But remember, they said round to a whole number, so it'd just be 17%. All right. So customers at the old store bought milkshakes 17% of the time. Now we got to get the old store. That was the old store. Let's look at the new store now, right? Because the new store still sells the same things, but they have a different amount. So if I look at the new store, calculate the percentage, I want to find the new store right here, and I want to look at the milkshakes again. Well, remember, a percent is a part to whole relationship. The part here is just those milkshakes, just those milkshakes. So the part here would be the 7,500. The whole would have to be the total number of products sold. So here I've got 26,300 plus 7,500. That would be 33,800. So the whole of all the products sold, there are 3,800 total of all products. So what percent of the time did customers buy just milkshakes? Well, change it to a decimal, put in calculator. That would be 20 or I'm sorry, 0.22, like 2 if you round it to 3. We're going to multiply it by 100 to get a percent. This will be 22.2%, but they said whole number. So really, it would just be 22%. So that means that customers at the new store bought milkshakes 22% of the time. Now, the last part of this question is asking us of all the milkshakes sold at Rebecca's ice cream shop, blank percent were at the old store. Well, I know that for milkshakes at the old store, they sold 10,400. At the new store, they sold 7,500. So, of all the milkshakes sold, what percent was just at the old store? So, let me once again find the total because a percent is a part to whole relationships. I got to find the total number of milkshakes sold. That was, wait, plus 7,500. That was 17,900. I'm gonna find what percent were just at the old store. I'm gonna do, okay, the total over, okay, the old store, number of milkshakes at the old store, 10,400 over the total amount of milkshakes, 17,900. And if I do that, that as a decimal would be 0.58, and you can put 581, all right? Convert that to a percent, multiply times 100, you would get 58.1%. Round it to a whole number, it would just be 58%. So 58% of all milkshakes were sold just at the old store. Right, this question is asking us which graph best represents the function f of x equals 0.5 parentheses x squared minus 6x minus 2. This is definitely just a Desmos question, so just put it into Desmos and see which graph best matches. All right, this is what I get when I put this function into Desmos. I see when I do that, I have a y-intercept that is about right here. I have a y-intercept that's right here at like negative 0.3, and a y-intercept right there at 6, and I have a like vertex on it. So just see which graph matches up. Now, because this is opening up, I know it's not going to be opening down, not going to be that one, or it's not going to be that one. Right? Out of these two, which one is going to be it? Well, this one has a negative 6 over here and a positive 0 point something. Well, no, that wasn't the same graph. The graph was like negative 0 point something over here and then 6 over here. So it has to be this answer right here. Right, this question says that the table shows the first 5 terms in a sequence. This table terms which equation represents a sub n, the value of the nth term in the sequence. Well, they don't tell you this here, but you can tell by just looking at all the answer choices that this is an arithmetic sequence because all of these look like arithmetic sequences. And remember, arithmetic sequences are addition patterns, all right? They are addition patterns. So they're adding or subtracting the same thing each time. So if I look here, and see this specific sequence, like what is it adding by each time? Well, let me see. I can take the differences. Well, I can do 6.25 minus 2.5. 6.25 minus 6.25 minus 2.5 would give me 3.75. So that means I'm going up plus 3.75. And I can check that again. Okay, let me see. The 6.25 plus 3.75, does that equal 10? The answer is yes. 6.25 plus 3.75 equals 10, and then 10 plus 3.75 does equal 13.75, and then so on and so forth. So here, I've already found the common difference, all right? I've already found the common difference here. Remember that for a arithmetic sequence, the formula that you are also given on the test, you don't have to memorize this formula, you just need to know how to use it, is a sub n equals a1 plus d parentheses n minus 1. Remember, this right here, this a sub 1, this was the first term, This right here, d, was the common difference. And remember, n was the term number if you wanted to find a specific term. But here, we just want a formula. So we're going to keep n as n. So I can plug all these in. I can say, wait, the answer to find any term, okay, a sub n, let me write that over here. To find any term, I can do a sub n equals a1 here, the first term, if I go back to my table, the first term of my table is 2.5. That's the first term right there. So equals a1, 2.5 plus the common difference, and it is positive d here because the table is going up, so it's going to be plus 3.75 parentheses. Remember, n is if you're finding a specific term number. We're not finding a specific term like the fourth term or the 10th term or the 20th term. So we're going to keep n as n minus 1. Now, you don't see that answer up here, so you have to simplify this. You could always kind of like put this in decimals and see which one of these match this one, or you could just simplify this, all right? I could distribute first 3.75 n times n, and then 3.75 times -1, all right? I would get 2.5 plus 3.75 times n is 3.75 n. 3.75 times -1 is minus 3.75. So now I can combine like terms here and kind of run out of space. So I got 2.5 I can combine with minus 3.75, right? 2.5 minus 3.75 would be negative 1.25. So I got, I can write that down. See, I don't have enough room. I'll write that up here, right? So I would have positive 3.75 n, all right, minus 1.25, which would be this answer choice right here. Yeah, this question says that each side of a regular hexagon is m plus 12 inches. The formula for finding the perimeter of the hexagon is shown below. What is the same formula rewritten for m in terms of p? Now, if you remember, this is a literal equation, right? Because it has more than one variable, and we're trying to solve for a variable. So we won't get a numerical answer. We won't get a number. We're going to get an entire expression. So I want to solve for M. M in terms of P. So I want to make M kind of like the subject of my sentence, right? So that means I've got to move everything that's not M on this side. Now, the first thing I can do here, before I can move, I can't move this plus 12. This plus 12 is kind of like married to this M because they're inside parentheses. I can't just remove it. So instead, I'm gonna deal with the 6 first. Now, you might think here, okay, so it's saying 6 times m plus 12. You might think you might divide by 6, but instead, I might want to distribute first. I'm gonna distribute first. So I'm gonna get, okay, distribute that 6. I'm gonna get p equals 6 times m is 6m plus 6 times 12 plus 72. All right, now this looks a little bit more familiar. I want to solve for m still, so I still need to get m by itself. I'm gonna first subtract 72 from both sides to get rid of 72. Subtract 72, subtract 72. So I got P minus 72 equals 6M. Now I can solve for M to get rid of M. They're saying 6 times M. To get rid of times, I need to divide by 6. So I got P minus 72 divided by 6 equals M. Now, I would always distribute first if I can. What would have happened if you didn't? Well, if you didn't, you would have gotten 6 parentheses m plus 12. Let's say you wanted to divide by 6 first. You could have done that. You would have gotten p divided by 6 equals m plus 12. All right, now to get the m by itself, you got to subtract 12. But just notice something here. That answer is not up here. That answer is not up here because now you've got to make these a common denominator and everything, and it just becomes a little bit more complicated. So that's why we distribute if you can. I would distribute first and not necessarily divide by 6. All right, just distribute first because this answer is not equivalent to this because you have to find a common denominator here. This is not saying that. So that is why that's not the answer. So that's why I would just distribute first so you can get to the answer, which is p minus 72 divided by 6. Okay, this question says, over a period of time of several years, a park ranger kept a record of the number of foxes that inhabit the park where he works. He finds the number of foxes in the park is growing at a fixed percent each year. Which table shows the situation? Well, if I'm growing by a fixed percent, that means that the function type is going to be exponential. So basically, this question is asking me which of these four tables is an exponential table. Well, remember, exponential functions grow by equal factors. They grow by equal factors, so they're multiplying the same thing each time because factors mean multiplication. So it's going to be multiplication. It's going to be multiplication, all right? But with exponential functions, if you look at these tables, sometimes it's hard to tell what's multiplying by. So how can we make that a little easier? Well, because I'm multiplying by the same thing, I can take the ratio of the term of the second term divided by the first term when I take the ratio between any two terms. Let me show you what I mean. All right. So for example, is this table exponential? Well, is it grown by equal factors? Does each between each two terms, do they have an equal ratio? Well, let's see. I have 200 and 240, all right? I can do 240 divided by 200, second term divided by first term, that ratio there, let me get my calculator out. All right, 240 divided by 200, that ratio there is 1.2. So let's see, let's check, are these exponential? Well, let's take another ratio. I got 240 divided by 280, second term, 280 divided by first term, 240. That ratio there is 1. So wait, those ratios are extremely off. So they're not growing by equal factors here. So this table is not exponential, right? If I look at this one, let's see, 200 to 220. So let's do 200, 220. That ratio, second term, 220, divided by the first term, 200. That would give me 1.1. Let's see the next term, okay? 220 and 240. 4. So 244 divided by 220. Let's take that ratio. 244 divided by 220. That gives me a ratio of about the same thing. It's like 1.109. If we round that, that will be like 1.11. So that's about the same thing. Okay. So let's see the next one. I've got 244 and 268. Let's do, okay, second term, 268 divided by first term, 244, right? 268 divided by 244. That is, let's see, 1.098. If I round that to two decimal places, it would be 1.1. So wait, these have equal ratios between consecutive y values. So therefore, this has to be an exponential function. It's growing by a factor of 1.1 each time. All right. And you look at the other tables, like you do the same thing, take the ratios, they wouldn't match up. Like, this table right here, this table, not that table. Okay, this table right here. So the same thing would apply here if you just take these. Like you do the 200, 220, you would do 220 over 200. I think we already calculated that. That would be what? 1.1, right? That equals 1.1. But 250 over 220 would be 1.136. If you round it, that'd be like 1.13. Like that's not exactly the same thing. So that doesn't have the same ratio exactly. And then if you do 290 divided by 250, that would give you 290 divided by 250. That would give you like 1.16. So those ratios are not equal. All right, so that's not exponential. And then here, same thing, 210 over 200, that would give you 1.05, but 300 second term divided by first term, 300 divided by 210, that would give you like 1.428. That's way off. That's not growing by equal factors, all right? So that's why it has to be this table right here. Yeah, this question says that Anthony has visited 12 cities already. He has a goal of visiting at least 48. He plans to achieve this goal by visiting 6 new cities per year. Why? For the next several years. Which inequality and solution shows the amount of years that it will take for Anthony to meet his goal? Well, okay, so determine the variable y represents the amount of represents the years per year y, and I see that it's doing 6 new cities per year. So that should be 6y, 6 cities per year. So 6 per year. So there should be 6y. So it means I know it's not going to be 12y. I know it's going to be 12y. And he's already visited 12 cities. All right. So the number of cities he's already visited, total number of cities is 6 per year plus 12 that he's already visited. And because that has to be at least 48, at least, that means it needs to be 48 or more. So greater than or equal to 48. So both of these look the same. Both of these look the same, except for we just figure out, okay, which one shows the correct solution. All right. So to find that solution, all right, we can put this into Desmos. Help us find the solution here. Put it into Desmos. If you do that, you see you get here that the y values, if you look here, the y values are on 6 because the y here is 6 and they go more. So y can be greater than, and because it's a solid line here, be greater than or equal to 6. So which answer choice gives me a y value that is greater than or equal to 6? It is B. So that means that B is my answer here, right? Okay, this question reads, Courtney monitors the total number of newly confirmed COVID-19 cases in the world daily. The number of total COVID-19 cases days after March 1st, 2020 is shown in the graph below. What is the average rate of change, rate of increase between day 20 to day 25? Assume that day 25 is on the exact number, not above, right? So the average rate of increase, that sounds like the average rate of change, right? Remember, the average rate of change is the same thing as finding our slope. Same thing as finding our slope. So let me look at date. So I want to go from day 20, this is my interval, day 20 to day 25. So I need to find, okay, slope, I need x1, y1, x2, x2, y2. I've already got my x values, all right? I've got day 20 and I've got day 25. I just need to find what are the y values for those days. So for day 20, that y value is about 30,000. They said assume it's about 30,000. So day 20 is about 30,000. And then day 25 is about 60,000, all right? So now if I calculate the average rate of change here, I'm going to do, okay, y change in y over the change in x. I got y2 minus y1 over x2 minus x1. So that's going to equal, okay, I'm going to label these x1, y1, x2, y2. This would be 60,000 minus 30,000 divided by 25 minus 20, right? We can put that into decimals real quick. Press divide. Okay, 60,000 minus 30,000 over 25 minus 20. So it's about 6,000, all right? Because remember, we had to round. So it's approximately 6,000 COVID cases per year. Move the other way. So about approximately 6,000 per day, excuse me, day because it's days. So 6,000 COVID-19 cases per day is the average rate of increase between day 20 and day 25. Okay, this question asks which point is on the line described by the equation below. 2x minus 6y equals 2. Right? So I got 2x minus 6y equals 2. So I can put this into decimals. So I'm going to put 2x minus 6y equals 2, and then I can put all those points to see, okay, which one is on the line. Okay, negative 5, comma, negative 2. All right, that's on the line. All right, so I can technically stop, but I'm going to keep going just so I can see. I want to show you all of them. So I'll keep going just so you can see. Right, I can also, and I can label it to make it easier to see. I can put 5, comma, negative 2. That's clearly not on that line. I've got 5, comma, negative 5. You can kind of scroll down a little bit. That's not on the line, and label it to see it better. And then you have 2, comma, 2. That's also not on that line, all right? So that's why it's 5 comma negative 2. Okay, this question reads, an inequality is given below. 3x minus 6 is less than or equal to 5x plus 9. Determine which values of x are solutions to the inequality. Select yes or no for each value. Okay, so I'm going to put this inequality into Desmos. I'm going to put 3x minus 6 is less than or equal to 5x plus 9. And you kind of have to read this a little bit because it gives you this shaded, and it gives you an inequality because it's shaded and it's got a line, right? You've got to be able to read that this inequality is saying, this graph is saying that x is something to negative 7.5 because it's on negative 7.5 right there. You see negative 7.5. Well, here, because it's going this way, the x values that way get smaller and it's a solid line. So that means, okay, they get smaller, so it's going to be less than, but it's a solid line. So that's going to be, okay, less than negative 7.5. Or, I mean, you can also think about it like this. Here, negative 10. Negative 10 is over here. It's going to be to the over there. That's not in the shaded region of this. So negative 10 would not be a solution here, right? Negative 5 is right here. Negative 5 is in that solution set, yes, right? Positive 6 is over here. Positive 6 somewhere over here. That's in the shaded region, so yes, all right? And 9 is also over here, so that's also in the shaded region, so that also has to be a solution, all right? So you really just use decimals. You really don't, you need to know how to read this inequality, but you can also look at the axis and just see, wait, negative 10 is not in the shaded part, so it's not a solution. Yeah, this question reads, the function g of t equals negative 2t plus 100 represents the percentage remaining of a student's workout session after t minutes. The function is modeled by the graph. Which statement describes the domain of this function? Now, remember, when I say domain are all the possible, array, all possible x's. So what is the leftmost x value? What is the rightmost? Because I'm going to be moving left to right for domain. So let me look here. All the way left is this point right here, x value 0. All the way right is this point right here, x value 50. So when I write this inequality, because I have closed circles, it can be from 0, less than or equal to x, less than or equal to 50. So it means I know it's not all real numbers because it goes less 0, smallest 0, biggest x 50. I know it's not that because it needs to have 50 involved too. So the question is it all real numbers or is it all whole numbers? Now, just remember, when I say all whole numbers, I mean, okay, no negatives, no decimals. Okay, well, no negatives make sense because the smallest x value is 0. So it makes sense, no negatives. But no decimals, no fractions, well, on this, between 0 and 50, you have numbers like 1, 2, 3, 4, 5, 6, 7. Those are whole numbers. But you also have like something in the middle. You have like, okay, 7.5. You have that, right? You can have like 21.2. Like, you don't have to just have whole numbers. So you can also have decimals here. So here, it won't just be all whole numbers because we can have decimals. It's going to be all real numbers between 0 and 50. Okay, this question reads that a car is traveling 300 miles at a constant speed of 50 miles per hour, which graph represents n, the number of miles remaining on the trip as a function of t, the number of hours traveled. This word right here, remaining, is so important because it's basically telling me, wait, our trip, all right, if I have like a graph, our trip started at some number of miles, the y-intercept, and we're trying to see how many miles are remaining because we're going at 50 miles per hour. So we're trying to figure, okay, how many miles remains as we go 50 miles per hour? So it sounds like to me that the slope here, the slope needs to be negative because they want to see how many miles is remaining. So the number of miles is going to go down. Right? So the slope can't be positive here. The slope can't be positive. How many miles are remaining? I want to know, okay, the number of miles has to be going down. We started at this number of miles and it has to be going down because I'm figuring out what are the miles remaining. So that means now I know that they started traveling at a trip. It was 300 miles, 300 miles. So that's why both of these graphs here are at about, well, you can look at this one. Wait, this one's not even at like 300. So automatically, this can't be your answer right here because they started at 300 miles. That's not at 300 right there. So I mean, you kind of have to look very closely for that one. So that's why it has to be this answer right here because this one starts at 300 and it has a slope of 50 miles per hour because here, going from here to here, this went from 300 to in the middle is 250 in a total of 1 hour. So that has to be the slope of 50 miles per hour. Now, this one, let's say it was at, well, it's not at 300, but let's say here I'm going from here to here in 1 hour, right? This I would say is about like 310. This right there, that's 200, maybe about like 220-ish, maybe. So that's going down by a lot more than just 50 in one single hour. So that's why that one also is not correct. And this question says that a function is given below, f of x equals x plus 4, which is a true statement about this function, right? So outputs and inputs are what these answers are talking about. So remember, if you have x comma y, x's are always the inputs, y is always the output. So if it's saying, okay, the output value of the function is x when the input is 3. So that means that everywhere input is inside parentheses, all right? So this is the input. So it means when I put in 3, all right, this is just saying the answer when I put in 3 is X. This question said, okay, the output is X when the input is 3. So, okay, 3 plus 4. Wait, the answer when I plug in 3, f of 3, that equals 7. That's not X, so that's wrong. The output value of the function is 1 when the input is 5. Let's see. The input 5, so that's what I'm putting in. So the answer when I plug in 5, that's what they're saying. Answer when I plug in 5 equals x, the input 5 plus 4. That means f of 5, the answer when I plug in 5 is 9. That's not 1. Nope. Okay, the output value of the function is 3 when the input is x. Well, okay, that's my input right here. When I plug in x, that means I'm plugging in a variable, so x, all right? The output when I plug in the input x is just going to be the same thing, x plus 4. I mean, I'm not plugging in any value. I can't get a value by plugging in a variable, so that can't be right. So it has to be this answer right here. But also, let's see, we can check it. The output value of the function is 5 when the input is 1, when the input is 1. So inside parentheses, input. Remember, this is just saying the answer when you plug in 1 is 1 plus 4. That means f of 1 equals 5. The output is 5. That's correct. So it has to be the answer. You didn't even have to do as much as work as I did. Like, there's no way you're going to plug in a number and get a variable or plug in a variable and get a number. All right. So you know those excess ones, they have to be incorrect. So you don't really have to check those. You're not going to plug in a number and get a variable or a variable get a number. That just doesn't make sense. Okay, this question says that Mary has 3 different bank accounts at the local bank. Account 1 has an initial value of 200 and doubles every 12 months. Account 2 has an initial value of 100 and grows by 2% every 3 months. And account 3 has an initial value of 300 and decreases by 30 each month. Identify each account as linear or exponential. Well, this one is not. This one's not too bad. Account 1, remember exponential keywords. Exponentials will either grow by a percent each time, right? Exponential functions, percent, or I got keywords like double, half, triples, third, fourth, quadruple. So account 1 has an initial value of 200 and doubles every 12 months. The keyword doubles makes this exponential. Account 2 has an initial value of 100 and grows by 2% every 3 months. That percent would make this exponential. And account 3 has an initial value of 300 and decreases by $30. So every month, 30, 30, 30, 30. So that's going to be linear. Okay, this question says that a school ordered 3 different types of jumbo cookies to sell at a fundraiser. There are X chocolate chip cookies, Y sugar cookies, and Z peanut butter cookies. The total cost in dollars of the cookies is given by the expression below. 2X plus 5, 5 plus 3Z. What do the coefficients in the expression represent? Well, remember these variables here are representing the cookie amounts, right? The number of cookies you buy, right? So X is chocolate chip and Y is the sugar, all right? So I probably got that right. And then Z is the peanut butter, right? The number of cookies you buy. So when you have something like, so this is saying like this 2X is saying 2X is saying like 2 per cookie, right? 2 what per cookie? Well, 2, what do you exchange for cookies? You exchange money, $2 per cookie. So A is not correct because it's not the number of each type of cookie. Like, this is not saying you only order 2 chocolate chip and 5 sugar. This is saying it's 2 per chocolate chip, 5 per sugar, 3 per peanut butter. It's a per, that coefficient is per. So it's not the number. The total amount in dollars spent on each type of cookie, well, that's not what that is necessarily saying. It's not saying you spend a total of $2 on chocolate chip because it's saying 2 per chocolate chip, 2 per cookie, right? $2 per cookie. So it's not that one. The cost $10 of each cookie type. Well, that makes sense because here I got 2x, 2 per chocolate chip, 5y, 5 per sugar, 3z, 3 per peanut butter, $3, $5, $2. So that makes sense. And then the last one doesn't make sense because the number of cookies purchased. Like you didn't buy two you didn't buy 2 chocolate chip, you didn't buy 5 sugar, you didn't buy 3 peanut butter. You're spending 2 per chocolate chip, 5 per sugar, 3 per peanut butter. So no, that one's not right. Cost, because we're talking about cost here. Okay, this question reads: the population Y of a city is changing according to the equation y equals 250,000 parentheses 0.97 to the power of x, where x is the number of years after 2010. What is the correct interpretation of 0.97 in this equation? Well, remember, this is exponential because here I've got this x as an exponent, right? So remember, you're given this in your reference sheet. Y equals a times b to the x. This is just the general form of any exponential. Remember, if I want to know if something's growth or decay, I look at b, right? Because b tell me if it's growth or b tells me if it's decay. Right? Remember, it's growth if that b is greater than 1, decay if that b is less than 1. Here, the b is 0.97, it's less than 1. So it has to be decaying. This population of the city has to be going down. So is it by 3% or by 97%? Well, to figure that out, I can take that b value 0.97 and just take away that 1. Take away that 1 is kind of like that 100%, the starting amount. Take that 1 away. 0.97 minus 1 is negative 0.03. So it's saying it's going down by 0.03, but change that to a percent. You just need to multiply by 100. So that would be, okay, down by 3%. So it has to be that one. Okay, this question asks me which coordinate plane shows the graph of the function described below. F of x equals parentheses 4 minus x, parentheses x minus 2. I can just put this into decimals. Now, if you look at this graph, it's opening down, right? It looks like this, right? And let me just check my intercepts, all right? Try to match it up. Sometimes you have to be careful because, like, it can be off by the smallest little thing. So here you have x-intercepts of 2 and 4. It's opening like down. And you've got an x-intercept of 2 and an x-intercept of 4. So that means just look at your answer choices carefully to see which one matches that. So here, this is going down, and look, it has x-intercepts of 2 and 4. So this has to be the answer here. If I look at these other ones, this one wasn't opening down, that one's not opening down, and this one doesn't have the correct x-intercept. It was positive 2, positive 4. This has negative 4 over here, positive 2. So just look carefully at your graphs when you put them in decimals. Decimals will always highlight those points for you too, so you don't have to go looking for them. Okay, this question is asking you to solve for x. 2x squared plus 11x plus 9 equals 0. You can, when it ever says solve, it's just saying find the solutions. You can always find the solutions by looking at decimals. Remember, solutions are where the graph crosses the x-axis, all right? Those are where you find the solution. So if you put this in, you see you got solutions negative 4.5, because that's the x-intercept, and negative 1, where it crosses the x-axis. Remember, this is the x-axis right here, right? Negative 4.5 and negative 1. So if I go back to my problem, right? Well, I know it's going to be here, it's going to be negative 1, so it has to be this one. Remember, let's say they give you a fraction. Let's say decimals gives you a decimal, but your answer choices are only fractions. How do you get a fraction in decimals? Well, right, right, you could have put negative 4.5 into decimals. You see, you get this button right here. Change it to a fraction by just pressing that button. Boom. And you got negative 9 over 2. So that's why it has to be that answer right there. Okay, this question says, given the formula F equals m times A, where F represents the force, m represents the mass and has units of kilograms, and A represents acceleration and has units of meters per second squared, select an appropriate measurement for F, force. So we know that F, according to the problem, F equals m times A, where m was given, they said, in kilograms, all right? So kilograms times, well, A was given in meters per second squared. That's how you measure acceleration, meters per second squared. So that means that F would be equal to the kilograms times meters per second squared. This has to make the most sense. All right. Right, this question reads, Barbara graphed the system of equations below to find the solution to the equation negative 0.37x plus 2.3 equals 7.8x plus 43.25. F of x equals negative 0.337x plus 2.3, and g of x equals 7.8x plus 43.25. Which statement best explains why the graph helps solve the equation? All right, so here the answer is talking about intersection points. Let's put this into Desmos. So right off the bat, if you put the original equation they give you into Desmos, you get the solution of negative 5.012. So I know that's going to be my solution here. So let me okay, no, okay, I know it's going to be negative 5.012. So that means, or negative 5.012, if you round it, is negative 5.01. So that means I know it's not going to be 4.16. It's not going to be 4.16, all right? Now I just have to correctly identify the intersection point. So that was the original equation. Now let me put in these two functions to see what is the intersection point, all right, of this system that basically is the same as this equation. They just changed it to a system. So let me put that into Desmos. Well, if I look here for these two functions, my intersection point that I get is negative 5.012 comma 4.1556. If you 555, if you round those to two decimal places, you get this one right here, negative 5.01 and 4.16.